So, a very good morning to my ever inspiring professors and my dear students. So, the topic assigned to me was thermodynamics and P block elements. So, let's get into this topic. So first we can see the general introduction. Before that, we can see one of the most favorite quote given by Albert Einstein. So the classical thermodynamics is the only physical theory of universal physical theory of universal content which I am convinced will be never overthrown. So it was given by Albert Einstein, one of the most famous quote that he was well convinced by the law and the concepts of thermodynamics. So let's see the general introduction. So the term thermodynamics means flow of heat and is derived from the Greek word thermos, which means heat, and dynamics, which means flow. So in our day-to-day life, we come across many useful reactions such as burning of fuel to produce heat energy, flow of electrons to the circuit to produce electrical energy, metabolic reactions to produce the necessary energy for biological functions, and so on. Thermodynamics is the study of transformation of energy, explains all such processes quantitatively, and allows us to make useful predictions. So, however, over time, the laws of thermodynamics were developed and helped us to understand the process of steam engine. So, first they have a discussion and they have ever discussing thought in of steam engine related to the first concept which arrived in thermodynamics. So after that, some other laws were derived by a famous chemist or physicist. So these laws have been useful to deduce powerful mathematical relationship applicable to a broad range of processes. Thermodynamics evaluates the macroscopic properties, which is of heat and work, and their interrelationships. The first two laws summarize the actual experience of interconversion of different forms of energy. This third law deals with the calculation of entropy and the unattainability to absolute zero Kelvin. Thermodynamics carries high practical values, but it bears certain. So even though it have good concepts related to heat and work, and the first concept arrived at steam engine, even though it has some limitations. So the next we have to be well versed in certain definitions around thermodynamics. The first one was system and surroundings. System. The universe is divided into two parts, the system and the surrounding. The system is the part of the universe which is under thermodynamic consideration. It is separated from the rest of the universe by real or imaginary boundaries. Example, the system may be water in a beaker and a balloon with air and an aqueous solution of glucose, which is of carbohydrate. So on these basic physical and chemical properties, system can be divided into two parts. A system is called homogeneous if the physical state of all of its constituents are same. So for that we can take example of mixture of gases, and we can say the completely miscible mixture of any liquids, etc. So a system is heterogeneous if the physical state of all of its constituents are not the same. Example, mixture of oil and water. So then we can see about surroundings. So everything in the universe that is not the part of the system is called surrounding. So then the term comes a boundary layer. So anything which separates the system from its surrounding is known as a boundary. So this is the pictorial representation of system, surroundings, and boundary. So this is of system, and the layer surrounded by the system is boundary, and the outer area is known as surroundings. So there are three important types of systems. One is the isolated system, closed system, and open system. So let's see some definitions for isolated system, open system, and closed system. So for an isolated system, a system which can exchange neither matter nor energy with its surroundings is said to be an isolated system. So closed system means a system which can exchange energy but not matter with its surroundings is said to be an closed system. So then open system. The system which exhibits both energy and its matter to its surroundings is said to be an open system. So these are the basically three types of systems. Then we can see the properties of these systems. So there are two properties which is mainly classified, which is extensive properties and intensive properties. Extensive properties. volume, mass, amount of substance, which is in the ratio of mole, energy, enthalpy, entropy, free energy, heat capacity, which corresponds to extensive properties. Whereas in intensive properties, molar volume, density, molar mass, molarity, mole fraction, molality, specific heat capacity, which corresponds to intensive properties. So thermodynamic process. So the definition, we can see the definition of thermodynamic process. The method of operation which can bring about a change in the system is said to be a thermodynamic process. So the certain processes such as heating, cooling, expansion, compression, fusion and vaporization are the examples of thermodynamic process. So then we can see about the types of processes. There are 7 types of processes in thermodynamic. So which is of reversible process, irreversible process, adiabatic process, isothermal process, isobaric process, isochoric process and a cyclic process. So we can see generally, so what happened to each process if under certain conditions. If it is an adiabatic process, the heat will be 0. If it is an isothermal, the change in temperature will be 0. If it is an isobaric, the pressure change in pressure will be 0. Then in isochoric, the change in volume will be 0. In cyclic, all the process will be in 0 state. So under certain conditions, these processes are said to be isothermal, reversible, irreversible, isobaric, isochoric and adiabatic. So then we can see about the zeroth law of thermodynamics. So the physicists and chemists which have a very serious discussion in deriving the laws of thermodynamics. So they cannot avoid whether it is in first law or second law. They concluded that we can keep it as a zeroth law of thermodynamics under the various thermodynamic equilibrium conditions. So, in the zeroth law of thermodynamics, also known as the law of thermal equilibrium, was put forward much after the establishment of first and second laws of thermodynamics. It is placed before the first and second law, and it is possible to provide the logical equilibrium that was given by each state of the system. So the law states that if two systems are in equilibrium, then the third state of the system will be also in equilibrium under thermodynamic conditions. So this is the zeroth law of thermodynamics. Once again I repeat. So if the two states of a system are in equilibrium, then the third state of a system will also be in equilibrium. So this is said to be an zeroth law of thermodynamics. So then we get into one first law of thermodynamics. So the first law of thermodynamics is also known as the law of conservation of energy, which states that the total energy of an isolated system remains constant throughout the changes from one state to the another. Okay, once again I repeat. So the total energy of an isolated system remains constant from each state of the system to the another state. So from one state to the another state, there will be a certain heat transfer, work done, and the internal energy which applied to the system. Okay, so this is the famous derivation given by first law of thermodynamics, when the initial state of energy is subtracted by the final state of an internal energy, I mean a reactant and product, in the form of an reducing state, we get the transfer of heat minus the work done. So E2 minus E1 is equal to Q minus W, which is Q is of heat and W is of work done. So this is the first law of thermodynamics. So these are my references for thermodynamics, and this is my bibliography. And thank you. So then we get into the topic of p block elements. So this is one of the most classified and discussed representative elements in the periodic table. So we can have some general introduction on p block elements so that we can able to identify which elements corresponds to which properties and their various specific characters of each elements. So p block elements belonging to groups 13 to 18 of the periodic table are called p block elements. So these are the general electronic configuration of p block elements. The p block elements have characterized by the valential electronic configuration, which is of ns2 np1 to 6. So basically they are known as representative elements. So in that representative elements there are two classification. One is in S block elements and the other one is P block elements. So it is also known as in main group elements. So today we are going to see about the some of the concept. We can able to part that we are going to see about P block elements, so which is of representative elements or main group elements. So the inner pair effect. So one of the most important definitions we have to classify in P block elements by means of valential electronic configuration is inner pair effect. The tendency of ns2 electron pair to participate in bond formation decreases with the increase in atomic size. Within the group, the higher oxidation state becomes less stable with respect to the lower oxidation state as the atomic number increases. This trend is called inner pair effect. In other words, the energy required to unpair the electrons is more than the energy released in the formation of two additional bonds. So we can see various families which comes under P block elements. So the elements of group 15, nitrogen, phosphorus, arsenic, antimony, bismuth belong to the configuration ns2 and np3. So oxygen family. Group 16 of periodic table consists of 5 elements, which is of oxygen, sulfur, selenium, tellurium and polonium. Their general electronic configuration is ns2np4. The halogen family. Group 17 elements, fluorine, chlorine, bromine, iodine, astatine and belong to the halogen family and their general electronic configuration is ns2np5. Group 18 elements, helium, neon, argon, krypton, xenon, radon, corresponds to group 18 elements. They are also known as noble gases. So their general electronic configuration is ns2np6, except helium, which has high electronic configuration, is 1s2. They are also called as noble gases because they show a very low chemical reactivity. Then group 15 elements, we can see the properties atomic and ionic radii. Covalent and ionic radii increase down the group. There is appreciable increase in covalent radii from nitrogen to phosphorus. There is small increase from arsenic to bismuth due to the presence of completely filled d or f orbitals in heavy elements. So we can see the definition about ionization energy. It goes on increasing down the group due to increase in atomic size. Group 15 elements have higher ionization energy than group 14 elements due to their small size of group 15 elements. Group 15 elements have higher ionization energy than group 16 elements because they have stable electronic configuration, that is half-filled p orbital. So one of the most important definition, allotropy. If there is an allotropy, we have to know about catenation, right? So allotropy, all elements of group 15 except nitrogen show allotropy. Then catenation. Nitrogen shows catenation to some extent due to triple bond, but phosphorus shows catenation to maximum extent. The tendency to show catenation decreases down the group. Oxidation states. So the common oxidation states are +3, +5, -3. The tendency to show -3 oxidation state decreases down the group due to decrease in electronegativity, which is due to increase in atomic size. So the stability of +5 oxidation state decreases, whereas stability of +3 oxidation state increases due to inner pair effect. Nitrogen show oxidation states from -3 to +5. Nitrogen and phosphorus with oxidation state from +1 to +4 undergo oxidation as well as reduction in acidic medium. This process is called disproportionation, and this is in reaction. So 3 moles of nitrous acid which reacts with nitric acid in the presence of water and nitric oxide. So these are some basic reactivity conditions, and hybridizations are awarded to those elements which is having weak van der Waals force, and their boiling points are given because ammonia is more basic, ammonia have more boiling point because of its hydrogen bonding. They are bonded very tightly. Then the bonding angle in the range of ammonia, arsenic and bismuth are given with their bond angle. So then the electronegativity of nitrogen atom is always highest. Therefore, the lone pair of electron towards the nitrogen and hence more repulsion between the bond pairs. Therefore, bond angle is always highest. After nitrogen, the electronegativity decreases down the group. Then the basicity also will be decreases due to the nitrogen having a lone pair of electron on it. So then we can conclude group 18 elements. So ionization enthalpy, they have high ionization enthalpy because of completely filled orbitals. Ionization enthalpy decreases down the group because of increase in size. So there are three properties we have to know: atomic radii, electron gain enthalpy, melting and boiling point. So atomic radii increases down the group because number of shells increases down the group. Electron gain enthalpy, they have high electron gain enthalpy because of stable electronic configuration. Melting and boiling point, so low melting and boiling point because they have weak dispersion forces are present in it, hence we have a weak melting and boiling point. So these are my reference for p block elements, and thank you one and all.